Hello, my name is nigelargriffiths. I work in IBM Power Systems. You can see my Hotmail address down there if you want to talk about this with me. And we've got a little tiny URL for nextract plus. Now, this is the second movie in the series on nextract plus, and we're all about the data. This time we're talking about getting the data out of the HMCs and the REST API, data formats and formatting with Python, pushing the data to InfluxDB, and then the actual statistics before and after we do all this. The little diagram in here shows the data. Not very much actually comes from the operating systems themselves. Most of it comes from the Power VM, or really speaking, the virtual I/O server and the Power hypervisor via the service processor. All gets collected in the HMC. This REST API provides that to nextract plus. It pushes it into InfluxDB. Grafana gets the data, uses InfluxDB as a data source, and shows us all the graphs on the screen. And we had a different video about looking at all the graphs and the details there. Diving in, we have the examples of the servers here in the Power9 range. And we're going to collect the information, the data, from the service processor and the virtual I/O server. Now, we're going to assume that you've got fairly recent firmware on your Power8 or Power9 server. Now, we can do some Power 7, I've done a quick check on that, but I'm not going to waste my life debugging those older things, particularly if you're not on the latest firmware level. I'll get much more interested if you wanted Power 6 or Power 7 support. If you had, say, 40,000 euro dollar pounds, I'd get more interested in it. But as I'm doing this in my own time and at weekends, also we need the VIOS server, which is now at 3.1. Nobody should be running the VIOS server 2.2 because it's out of date, and I'm pretty sure it's already out of support, so we're not going to even try these older VIOS servers. I have none in my computer room. They may work, they may not. Don't phone me if they don't work. Then we've got to look at the HMC. Now, we've moved away from the Intel-based series of HMCs. The last one in the series is called a CR9. Now we have Power-based HMCs. Power8 is the one out here. It's called a CR1 in the new range. And I'm going to assume that you got the pretty near the latest software levels on your HMC. This is in the 9 series. Now, I have tested it with some older ones, and particularly I've tested it on some of my colleagues in my computer room have some of the Intel ones. One of them has a CR7, and it is so slow. The current ones might take 4 seconds or so to marshal some of the data. The older HMCs were taking 90 seconds to do the similar sort of operation. Probably get away with a CR9 if it's got enough memory. We're going to pull on the REST API on the current HMCs. That's the extract plus is going to push that data into the Influx database, and then the Grafana is going to pull it out and put them on a graph inside one of the popular web browsers. nextract plus, I'm using regular updates, roughly once a month at the moment. We're still doing some sort of rapid development and fixing up the last few problems with some of the more esoteric data. The vast bulk of it all works fine now already. I'm currently using InfluxDB 1.8. There is a 2.0 out. I haven't tried it yet. I'm told it's 100% backward compatible, so that should be working as well as you're using InfluxDB in the cloud. And Grafana, I'm using 7.4. Okay, so the first thing we have to do is activate the data collection on the HMC. By default, it doesn't bother, and it's called the Performance and Capacity Monitoring, PCM. We have to switch that on for individual servers that the HMC is controlling, the performance stats collection. Now, you want to do that probably for all servers, if they're all Power8 and Power9, for example, or just the ones you want to monitor. If you've got some older machines, you can exclude those there. Now, it can take 10 minutes to actually start up. You click the button and it seems to ignore you. Well, if it's the first time you started that, it's going to have to start a database, load a bunch of tables in it, start some daemons. They're actually going to capture the data every 30 seconds or so. And so it takes a while to build up. How do we switch that on? What's this the HMC 9 series looks like? If you go to a particular machine and you click on that tiny little pie chart, then you'll get this popping up. And you can see here we've got a 0 under data collection. The 0 or the O means off. If you click that, remember I said it won't immediately go and do something. If you go back to it 10 seconds later, you'll find it still looks like it's off. So don't fiddle about with it, just let it go. Just one firm press and it'll do it. And give it a few minutes, then it should look like this when you go back to it. So we've got a 1 in there, or is it an I don't know. And you get the actual stats are being collected as a little summary in this panel. At the bottom of that panel, you could say Review Performance Dashboard, and they put an awful lot of work into that. I find it rather complicated but limiting, because I want to decide what period, I want the past year, I want to go this month with 6 months ago, those sorts of operations, and you can't really do that with the dashboard. But it is there if you want the very basics and you haven't got any other way of measuring things on your HMC, then it does do a pretty good starter job. But I much prefer having the data in a proper database and I decide what the graphs look like. Okay, so we got a Python 3 code which makes up the nextract, plus there's the tiny URL, or the great big one if you want to go for that instead. I'm told that some customers can't use tinyurl.com. That's pretty mad as far as I'm concerned. You look down that article that's about it, it's quite big now, it keeps growing and they put more things into it. Looking for the download section, and this is a version 32. 34 is coming out tomorrow, I think. So that number will go up over time. And it's a small zip file. I mean, it's tiny, really. It's got the first two things is this HMC PCM. This is a module that I created that will talk to the HMC and understands its crazy language. When everything's working, you'll need a Grafana dashboard that matches the stats that we're collecting. And so that's a great big part number in here, formatted in JSON, the configuration of how it draws the dashboard. I also push that up to grafana.com, so it's a regular dashboard in the future. That'll be the way you get it. You'll also need the InfluxDB Python 3 client module, so you can talk to InfluxDB very simply, and there's a couple of standard Python modules that you'll have to download if you haven't already got them. When you get the program, we have to select some configuration information. You can see that at the bottom here, how to log on to your HMC and how to log into the InfluxDB. You can either hard code it in the Python, you just look at the first dozen lines and you'll find lines like we have on the left in here, and you put the mode into hard code. If you put the mode as a mode variable, if you make that called HMC, it will take the hard-coded details, but it will look on the command line for the name of the HMC. If the username and password for the HMCs are all the same, like I created a HMC user for pulling down the REST API data, that would be a smart move. Then I could just direct the script to different HMCs if the usernames and passwords are all the same. The alternative is you create a little JSON file like we have on the right in here, and it all looks pretty the same as the code inside the program, except it's actually in JSON format with some brackets around it, and it's got colons. Up to you which one you prefer. The next thing is once you've switched it on, then the HMC starts collecting these internal stats, and it has a database covering the last 3 hours, which is fine. After that, it starts summarizing things down. You don't really want to get that summary. You'd rather put the details into InfluxDB, and Grafana could do the summarizing for us. So we need to collect these 3-hour blocks of data. Note, it's called process data, which is a 30-second interval. The 30 seconds is not an option. We can't change that because you feel like doing something different. That is what we get. We can, the syntax for getting the data, specified time ranges in that last 3 hours. You can't stretch the 3 hours, but you can say just give me the last hour's worth or something like that if you wanted to. But that makes coding very, very hard because you have to do maths on time ranges. So, for example, if you collected the last stats at 12 o'clock, and it's an hour later, and now you don't want to collect 3 hours worth of stats, you just want 1 hour of stats, then you think, well, hang on, actually, I want to make sure there's no gap between the two sets of stats, so I'll actually have to calculate 5 minutes before the 12 o'clock, which, that can be done, because if the 12 o'clock is actually midnight, in the middle of the night, then you'd have to go back 5 minutes into the previous day and change the day, and if it's at the end of the month, then you have to change the month, and if it's at the end of the year, you have to change the year, and then you have to allow for the fact, and then you got leap years, and you think, it's just, let's not just go there, because If you just get the 3 hours, it makes my life really simple in the code. But more importantly, if you request an hour's worth of data that you've already collected maybe an hour ago, you actually get exactly the same numbers because it's just coming straight out of the same database every time. And if you put that same data into InfluxDB, it doesn't mind. It will say, oh, we've got this timestamp and we got this number. Well, that's the same as the number we had before, so we'll just ignore it. But the point is, you don't end up with duplicate, data items with a couple of seconds difference, or the numbers are slightly different, and then when we're graphing it, you've got to sort of, well, at midnight it was 3 and 4, so what do we do? No, because you get the same data every time, we can just ignore it. We can just throw it in the database, and the database says, oh, so what? So you could do every, let's say every 2 hours. That gives you a nice overlap. If you did it every 3 hours and left like 5 seconds in between or something, when you come around to collect the data, there's 3 hours worth of data that you need. But what happens if your HMC is powered off? Maybe somebody's rebooting it. Maybe there's a power cut or your network went down for 5 minutes or something. Now, it's not critical that we don't have gaps. I mean, the world is not going to stop turning because we missed 5 minutes worth of stats in it. Okay, so maybe you go for every 2 hours and you get an hour's overlap, and that will allow for the HMC to be down if it all went wrong. And that works fine. But the trouble is then you have to wait. If your timing's bad, you might have to wait for 2 hours before the new data comes. So you're looking at it at 2 o'clock and you've got nothing from this half of the day yet. Now you could say, well, if I want it right now, I could just run the script again manually and get the data in, but maybe you don't want to do that. So maybe you run it once every hour and you have 2 hour overlap. That's comfortable. It doesn't cost you an awful lot. The HMC has to find the data and produce the JSON data again. It doesn't take that long on a new HMC, so that's fine. Now, in actual fact, I do it every 10 minutes on my machines because keeping the HMC busy is not my problem. If I'm trying to debug and improve the program, I want a snapshot in the next 10 minutes so I can actually see some data by the time I make a cup of tea. You will have to decide what you do. There are the options in there. And don't ask me to try and fiddle about with this. The code for nextract plus is only 600 lines of Python. It's extremely simple. It's sort of very repetitive for the different sorts of data because there are subtle things different between all the sorts of data. But if you want to change it, you go right ahead. I got no problem with that. Just don't ask me to do it unless you've got your checkbook ready. Right, now the data we can actually get back is very complicated XML. I've never seen anything more complicated than this level of XML files. So you ask it to give us a 3 hours, or you ask it what servers have we got, and it gives you a list, and you select the ones you want that are actually collecting data. Then you ask for the performance stats for those particular machines, and it sits there extracting the data and creates a bunch of files on the HMC, and then it gives you an XML file full of the names of the files with the JSON in it. So you have to go back to the HMC to say, give us this file name that you just told me about, and then it actually provides you with the JSON files. Now, the JSON file format is a lot simpler than XML, but it is pretty complicated because it's very highly nested. We'll have a look at it in a second. But if you go to the nextract plus website and you go to reference materials, you'll find down the bottom there's 2 links here into the IBM Knowledge Center. One of them is for the managed system, and this provides you the overall stats for the managed system, the server. It also includes some things about the hypervisor in there, and then it's also got data, performance data for the virtual I/O servers, because they're part of the system rather than your applications and operating systems. So that all comes in one file, and then there's a different one per logical partition on that system for each of them. So if you've got 10 LPARs, you get 10 different files, one for each of those logical partitions. So now we'll actually click on one of those, the first one in fact, and we'll actually have a look at some of the JSON data. You don't have to be a guru in JSON, it's fairly simple format, but just want to let you see what's going on. Okay, so very quickly, we're in the Knowledge Center. This is for the Power9 system. This would be the same page for every Power9 system. In here we got the HMC installing all sorts of things. HMC, Then we scroll down in here. Here's the PCM, performance and capacity monitoring. And then here is the processed and aggregate numbers for JSON in JSON format. So this is the definition of what you get back for every server, including the VIO servers that are running on it. So this is standard JSON with wiggly brackets to demark the various paragraphs or stanzas. We have some information at the top in here, which is pretty good. It says this is the time it started and stopped. If you grabbed a particular time range, you can confirm you got what you wanted. MTMS is the machine type model serial number. That's pretty useful. All these UID is completely pointless. It's internal numbers. I have no idea what they're for. If you went for the aggregate data, then you get the average, minimum, and maximums. But we've gone for the process data, so we don't get the minimums and maximums. Actually, if having the minimums are no use whatsoever, as far as I'm concerned, because we can get the Grafana to work any of those out if we wanted them over any range we want. This would be the minimum and maximum over the 30-second interval, so it wouldn't help. Right, now we're into the utilization numbers. You see this square back in here. This means there's an array. So there's lots of items in here, all exactly the same. If we collected 30-second samples for 3 hours, we got 180 snapshots. So what happens next is repeated 180 times. Then we got, in case there's a problem with a snapshot in here, we got some error IDs and error messages. They're fairly verbose, so there's some of them I really don't know, and people are going to have to raise PMRs against the HMC to get them explained or what you can do to get rid of them. One of the nasty things in here is if something went wrong, you tend to end up with all 180 of your samples reporting an error. And that gets pretty boring on the screen as the script is running, so it captures every error and only shows it to you once, which helps out. Right, now we actually get to some data down in here. This is the system firmware. I would call that the hypervisor. We've got how much CPU and how much memory the hypervisor is using. Remember, we ignore these bits out in here because we're using processed and they're not there. Then we got the server utilization numbers, and you can start to make some sense. We've got processor, memory, physical processor pool, as opposed to the processor in proc units. Then we got a shared memory pool if we got one of those. That's AMS. Then we got the shared processor pool. This is the ones that we use for controlling our licenses, for example, being able to set a limit on how much CPU power a database can take. And when you look at these numbers, okay, proc units, everybody else on the planet would call that a CPU cores or something, but that's what those numbers are, so they'll come out as numbers, decimal numbers coming out. Then we're going to go down to the networks, but of course there's more than one network in the system. These are the networks actually that the system is running, as opposed to the VIO server or the LPARs. So these are the hypervisor adapters that virtualize networks in this case. So we have SRIOV, and then we say, and it's on an adapter level, and then it's, oh, there's another bracket in here, so each one of these is actually for a physical port. So we can have multiple SRIV adapters with multiple ports in here. And this is one of the problems I'm working around at the moment because I didn't spot that bracket. There's also one in here for the HEAs, which I think were Power 6 and Power 7 had these adapters. IBM was jumping ahead of the game, and when the SRIOV became an industry standard, then we adopted those popular adapters. The stats are pretty much the same. Then we come down to another section of data in here, which is the VIO server, and then we have again the name of the VIO server, and we have the memory and processor, oddly in a different order to the one up there. Then we have networks, and we have generic adapters, shared adapters, virtual Ethernet adapters, and SRIOV logical ports in here. So again, we've got multiple ports going on in here. I think these here are generic adapters. This is when we're doing virtual SCSI. Right, then we got the storage down in here, and we have 4 different types of storage. We have the generic, and then we have the virtual SEA, and then we got the generic physical. That's the physical adapter we're moving the storage IO to. Then we have fiber channel adapters in here, and then we have the shared storage pool, a nice feature that I use. Right, so that's the system. There's another one down in here for the LPAR data, and that's quite a bit simpler, but it covers almost exactly the same sort of things. I'll just show you, if you slide down here, there's descriptions of all the fields we have up in here. But I keep finding some that it will say the memory used, and you say, well, is that in bytes, kilobytes, megabytes, terabytes? I don't know. It doesn't say what the units are, so I'll have to go. This is the incoming data. It's far too complicated to put into a time series database. If we go back up here, you can see the indentation here. Well, the first one's free, I guess. 1, 2, 3, 4, 5, 6, 7, 8 levels of indentation. Time series database will allow you to have 1. So what I tend to do is, you see it here, this is the VIOS server storage generic virtual adapter. So I roll those all together. So there'll be a measurement called VIOS server storage generic, and then there's the data in it. Right, back to the presentation. That was all about the input side into the nextract plus. Now look at the output side, and after it's gone into InfluxDB, we can actually ask InfluxDB to tell us what the data we actually got arriving. This is going to help a lot when you're trying to debug it as well, because you'll see, is the data there at all? Right, so you just type in influx return, and then you type in show databases, and then it gives you a name. Don't worry about internal, that's its private details. So here's my njmon. This is the temperatures in my computer room measured on a Raspberry Pi, and here's nextract plus. And then you select which of the database you actually want to work with. Nothing works until you actually type in that. So you use a particular database, and it says I'm using it now. If you type in show measurements, these are the new simplified JSON stats, if you like. And so remember I was saying you get VIOS server storage virtual, VIOS server storage physical. Rather than 3 levels of indentation in the middle of it all, we've pulled those together, and these are actually what will pop up when you're in Grafana when you're trying to select the data you want to graph in a particular graphing panel. Now these arrows are showing you there's a whole load of LPAR things at the top in here. Then there's, because it's in alphabetical order, then there's the server details, and then there's the VIOS server details. There's a lot of virtual IO server measurements in here. Now you can also, if you want to say like the LPAR details, in there's a whole bunch of numbers or configuration strings and things. So if you want to find out what they are, if you type in show field keys, then this thing is whacking up the screen, 10 screens worth of things. But you can see for the LPAR details, it says there's fields called these things. And if they're numbers, like the affinity score, for example, then you can draw a graph of that. Hopefully it's 100, because you've got high affinity. If they're strings, then you can put those out into a text graph. As a type of graph, a text string will just come out, and you can see the OS type and whether the LPAR is running or not, and that sort of stuff. And then it goes to memory, and it goes all of these one after the other. You probably want to catch it into a file, and then you can go around finding out if they're floating point numbers or integers and exactly how they spelt them, or I spelt them in the code. Most of the the labels, the field keys, are exactly the same as they are in the JSON that came out of the HMC. That helps a lot in keeping them sane and being able to backtrack to find out which one it's talking about. There's also a thing called keys. It's a bit more advanced level, but in the LPAR details, all of the JSON strings also have keys in here. So we can say, show me the LPAR details where server name equals, and then one of your server names as it appears on the HMC, and then you get the details about that server, for example. Or we could get the LPAR details for a particular LPAR name. If they're all unique, then you can just name the LPAR. That would make sense to me, but some people do the strangest things. But these are the keys that we can use to look up and refine the data to find the actual server and LPAR we actually want to graph on the screen. A couple of other things that would be quite useful. You can do a select. This is sort of SQL. This actually changes in InfluxDB 2, but at the moment you can do these look like SQL statements. Right? We select count of anything from server processor. This is one of the measurements. where the server name is, and this is the name of my red server as it appears on the HMC, and it's telling me that there's nearly 21,000 lines of data in there. And if you're first of all starting up, you can watch this number go up as the data gets added into your database. Gives you a positive feeling that something's going on and how much data there is. And maybe at some point you'll actually want to delete the older data because you don't want it to keep the database size down. Right, another nice one is, I mean, if you've got 21,000 data points in here, you don't really want to, select star from server processor because you'll get 21,000 lines of output. That's probably not what you want. Well, one trick is if you put in last in here, you get the last value. And so you can actually see what the numbers are actually like in here. So we have 4.15 entitlement that hasn't been used yet, for example. There's 16 CPUs in there and they're all active, and the utilization for red in the last data structure that we took, the last snapshot, it was using 9.6 out of the 16 CPUs. So I can quickly let you have a look at the data in any particular one. Check that it's not all zeros if you can't explain why your graph's not working. Okay, now when nextract plus puts the data into the Influx database, it actually looks like these. These are much simpler data structures which are in JSON. Here's the measurement and the name. Then there's the timestamp, pretty obvious in here. Here's the tags. So the server name in this case is all we've got. And then there's another one in here called fields. And so here's the actual data, the name, the label, and the data name. And data, name, and data, name, and data. And off you go for the various pieces of data for this particular snapshot that was provided by the HMC. Just letting you have a little look under the hood. This is actually referred to nearly as line data or line protocol that InfluxDB likes. But these are actual data structures that the InfluxDB Python module expects, and it deals with the details of talking to the InfluxDB. Just a few seconds to show you how to set up the configuration in here. This is the actual program that's going to run, a Python program. It's a fairly straightforward text program. Go up to the top. In recent months we've added some debug information. No need to go there unless things go horribly wrong. Remember I mentioned this mode in hard-coded. This is the one that actually set. Here's examples of the alternatives. Hard code has the details, it's just below. In here I'll show you in a second. If you say mode equals HMC, then it will take the hard coded details apart from the HMC hostname, which you'll put on the command line. Or if you put it into file, this will actually get from the command line a file name of the configuration that's in JSON. This is what the file will actually look like. You'll have to remove the hashes in the front in here, and so it's got the HMC details and the Influx database details. Here's the hard-coded things in here. I just put something in random. I run InfluxDB without a username and password for injecting data, just for convenience and laziness. And you can see it has to. I've got a nextract plus database in there where it wants to put the data. Okay, so that's how you set that up. Very simple, I hope. We're going to run it here deliberately on the screen, and this is the sort of thing it comes out with. This is it looking through all the servers and deciding which ones are okay to get the data from. Some of them don't have the aggregation and long-term stats switched on, so there's no stats for those. They tend to be about older machines. So this is a machine called Red, my favorite machine, and these are all the LPARs that are sitting on it. These are the actual LPAR names as you'll find on the HMC. So now it's going through cyan there. You see these added in here. This is where it's pushed records into the database. We don't let them build up to very large numbers, as we find we tend to get failures or it runs out of memory or something. This is it in here. The Ruby machine's got some odd things in here. It's got an SRIOV adapter that's there but not set up, so it calls that a technical error. Alright, and here it's got 2 VIO servers that are not running, and it regards that as an error. Why would you have a VIO server and not run it? Well, we use it for testing, so it's switched off some of the time. Another problem in here, network bridged utilization for Indigo. Okay, Indigo is just running a hard LPAR with its own adapters, so it doesn't like that configuration either. And it's plodding along in here. You'll find some things in here. See, it says received 11 files in 4 seconds. That's it. That's the HMC gathering the data and creating the files, and then we have to go and get them for each of the LPARs later on. Got a nice fast HMC in here. And there's another Power9. This is Gareth Coates' machine. And we're done. That's it. Now that's a nice fast HMC with about 10 machines or something, whatever it was, at that top list. And you can see in that last 3 hour period there's 104,000 measures. That's quite a lot of data that's been pushed into the database for all the LPARs and all the servers. And we're done for this video. Highlighting the fact, and then here what we've covered. Power8 and 9 as well, we're really supporting it. You may get away with older ones. You've got to have recent firmware, HMC and VIOS server, as I'm not going to try and get older versions working. You may get lucky. How to switch on the HMC stats from the HMC console. I guess you could write a script that does that automatically for all the servers, but that's an exercise for the student. We talked about this 3 hour window and processing it and how you want to stagger those so you can get data more often and with a bit of an overlap in there, but a good overlap is worthwhile in case the HMC is not there. Then we looked at the HSC data that was just returned in JSON. Then we looked at the data that we actually send to InfluxDB, and we've used the influx command from InfluxDB to have a look at the data that actually arriving and the formats it in and the actual names of the data. And then we looked at actually running the nextract plus. Hopefully it's nice and simple and it's pretty quick on new equipment. Don't forget to give us a thumbs up if you've liked or learned something on this video, and don't forget to subscribe if you want YouTube to give you warnings when there's new videos from me coming out. Thanks for watching.